Hi, Florin.
Hello, Simon.
We're rolling. Yeah, we're rolling. Hi.
Hi. We've decided to do a news session
We have.
to cover September and October.
Yeah. Is it news? Okay.
Well, new and exciting, let's say.
New and exciting. Yeah, or newish and exciting.
Right. So I gathered a couple of news myself. I
Go
think
on,
you have them as well. Let's kick it off. My first piece of news is Java 21.
Okay.
Java 21. Yeah.
Florent, tell me about the Java numbering, because it's a bit weird, isn't it? The way they number, how do they number their versions then? Java.
Yes. Java started numbering with version 1. They set on version 1 for ever. So they had version 1.1. Actually, they started with 1.0 something. Then the next major, quote unquote, was 1.1 and then 1.2. That basically means Java 2, I think, in today's world. And they had Java 1.5, which got slanged into Java 5.
Okay.
Actually, this was Java 5, and Java 5 introduced object templating, where you can put a generics on an object. You say a class, you define a class. This was a major release. You define a class having a generic type, and that type can become any concrete type that you can define. So, for instance, a class can be an animal, and that animal can be a cat or a dog. This was a feature that was present in C++ for a long time and was not present in Java. That was one of the most important releases, 10, 15 years and more ago. Then Java 8 came about. That was yet another major release of Java, which internally was numbered also very funnily 1.8. Back to your question. Then the numbering changed. Oracle acquired Sun, and as a result, they owned Java at that point. And Oracle stepped in, and I think as a result of that, many changes came about. The process that enhances and evolves Java, I think the governance got a bit straightened or changed at the least by Oracle, and therefore I don't have the detail, but the numbering has changed. So now the numbering is straight up. So after 1.8, it started with 9 and then 10 and then 11, and at some point Oracle decided to do half a year release trains, majors, so 12 releases a year, I believe. So, and after that decision, which didn't happen a long time ago, the year escapes me now, there is a much often release train for Java, as opposed to before. Before, there used to be quite a slow release rhythm. And now it's very fast. And it is so fast that at this point, Java has version 21. And some of these versions between, let's say, 17 and 21, even before that, 14, I would say, no major groundbreaking change has happened. And a few observers, including myself in the JVM area, sort of thought that a bunch of changes that have been adopted by Java, they have already been invented elsewhere. Scala is one of the languages which furthered the language, the JVM languages, and because Java was so slow, and then Kotlin came about. So Scala, you're very familiar with the OpenBank project. Scala came about with a bunch of very interesting changes, including pattern matching, destructuring, things that are not new at all in functional programming languages, but they're fairly new in the JVM. And then Kotlin picked up the baton, and they did a bunch of other changes, including coroutines, which is a method of implementing multi-threaded programming approaches on the JVM. Very interesting. And eventually Java caught up with many of these features. And now Java 21 is again considered as a major such release, on par with what Java 5 and Java 8 did back in the day. This is why it is interesting for us to talk about it right now. Java 21 is one of the releases which are generating a lot of buzz in the industry, and you see people trying to adopt that and upgrade.
A lot of what? It's generating a lot of buzz.
A lot of buzz.
I thought you said bugs.
No, it's a lot of buzz.
Okay.
Java, interestingly, they don't seem to have bugs, seldomly, but they're still present. Oracle managed to have an extremely stable released code and then process, right? And they managed to maintain and retain the talent that they had back in the originals. Almost of the Java developers, they're still around and architects. Yes. So Java 21 is out September. This is when the release has happened. There have been a bunch of beta versions before that, and now it's officially out. And I have tried it, and it works as advertised. They've introduced a bunch of things. I want to talk about maybe 2 or 3 of them. The upgrade process, as we had also in the past, it is quite painless. Java / Oracle, they have strived very hard to make backwards compatibility a feature of the language. Unlike Scala, which you very well know, that when they do a major release upgrade, you actually have to catch up the code in many dimensions. Third-party libraries become incompatible, and all sorts of side effects that you just don't want to have. With Java, this is actually not the case. You upgrade the JVM. At worst, you will have to implement things that have been previously deprecated, so you have plenty of time to change the deprecated code. Otherwise, it should just work out of the box. And I have upgraded. I have an open source project on my GitHub page, which is FlorinD, and that is a TensorFlow usage for Java, recognizing images. This project is a few years old, and it's been on Java 8 and I think on 11 for a long time. And now I have upgraded it to Java 21. Code is up to date.
FlorinD, or one word?
Yeah,
oh, yeah.
FlorinD.
GitHub/FlorinD. Okay, cool.
Yeah. And it actually worked right away. No problems. I had 0 issues with it.
Like upgrading the Java version.
Yeah. That worked quite well. Now, sadly, I didn't use any of the new features of the JVM, of the new JVM, but I'm planning on using that. It seems faster.
It sounds like a bit like the difference between Mac and Windows and their upgrade thing, right? So Mac is quite happy to break stuff, and applications have to be upgraded and all the rest of it. Whereas Windows, you have this like ongoing upgrade type approach.
You could put it this way, indeed. I would say that Java has created an industry standard in this so many years they have been around, that things just don't break when you upgrade. And this is one of the factors of success for Java itself. People stick to Java, and you have this duality in Java. You have the JVM, which is in itself an extraordinary piece of technology, and then you have the Java language. So when people talk about Java, they usually talk about the JVM and then the language. And therefore, having this 2 things that the Java developers have worked on in parallel. You can they made it quite quite possible to create multiple languages on the JVM, and you saw the explosion of that with so many things like Scala, Clojure, Kotlin.
So
I don't want to name all of the other ones, but
I've been also like digging in a bit to the JVM lately, and as is my wont, I like to occasionally learn a new programming language. And last month, or where are we? November, October. Yeah, this month was Golang.
Right, you did that.
Yeah,
let's put that on a side for a second, because I think that in itself is an extremely interesting
topic
discussion to be had. I want to talk about a couple of things on the Java, since we are on the topic of Java, and then we can switch to the other exciting things you've done.
Okay, but I have the JProfiler, right? So maybe at the end of the Java.
Oh, yeah, that's right. This is also exciting.
That's a Java thing, right?
Of course. It's okay. Got a couple of things on the JVM. What makes Java 21 so interesting? So number one by far is a new API, which is called virtual threads. Virtual threads are the aim of Java is to be able to work with multi-threaded programming in an extremely scalable way. We are in a world where you need parallel computing power, and Java has caught up. I wouldn't say slowly, but it a bit like behind other programming languages. Go is one of them. So Go is natively extremely scalable. So they are able to spin virtual threads.
So can you explain that for the complete, like non-computer person?
Sure. Yeah. So when you're talking about threads on a normal machine that we are developing on, threads are bound to the operating system threads. The operating system threads are being made available by the language interpreters, or when you do ahead of time compilation, the bytecode binds your code to the platform threads. So once you have one-to-one type of binding, you are actually constrained to how many operating system threads are made available by the machine or by the virtual machine, because you can have a Docker sort of environment, and that also is limited by whatever the provisioning has defined for that specific VM. And whenever you have more than that number of threads that your application uses at one time, you start Java in this case starts to put semaphores on the operations that it makes on those, or the CPU bound operations that it has. So to be able to stay limited on the OS threads, otherwise it's just not working. So a lot of
so basically thread sharing, basically.
Very, very likely. This is extremely close to what you're saying. So
and then you have this kind of waiting and blocking and all that kind of stuff.
Right, and that is it's causing thread management done in this way is not scaling properly, because you will always be bound in this way. There's other issues. Java, the JVM, whenever you have a new thread being instantiated, there's a bit of stack that is allocated alongside to be able to store and manage thread local variables. And that is, I think, 2 megabytes or something like that. Quite close. So the more threads you're instantiating, and the JVM does not stop you. You can create any number of new threads. They will wait for one another due to this binding that they have to the OS itself, but you cannot create an unlimited number because you're running out of memory in the JVM itself, because this is a non-zero memory allocation that happens. So Java 21, and before that, I must say, Kotlin did something quite similar with the coroutines. You have a new abstraction that gives more flexibility and control for developers, and it's called a virtual thread. And a virtual thread is not tied to a specific OS thread, but it still runs code on the OS thread. However, when the code running in the virtual thread calls a blocking operation, the Java runtime suspends the virtual thread until it can be resumed. And the OS thread associated with the suspended virtual thread is now free to perform operations or other virtual threads. So this fashion of implementing this threads, it frees up a lot of memory. You don't by virtue of implementation, the toll associated to instantiating this new virtual thread is not, it's very, very different from the 2 megabytes or whatever it's been before associated with instantiating a platform thread. And now you can instantiate virtually unlimited number of threads. Not that you will ever want to do this, but you're not being bound by the JVM heap memory itself. So you don't really have to think anymore of managing these threads. And they have had a long process of implementing the virtual threads, and now it's this new fashion of implementing is live. And what is also very interesting is that it is part of the same thread API that the Java has, which is something remarkable, because they have managed to maintain a pretty uniform thread interface, thread API, for so many years, including Java 21. They have a bit of change where you say thread of virtual. So you have to specify that if you want to start a virtual thread. But otherwise, all of the other operations are like incredibly similar, if not identical, to what you have done before. So you can actually migrate your threaded application in a pretty easy, cheap way.
But how often do you actually have to like program at the thread level? I mean, in Scala we don't do that, I think, right?
So we had this conversation, and I must say, in my last couple of projects, I had maybe once the need to work with this kind of individual service that has to scale. It was a data consumer that had to do a parallel operation to consume a stream of data and push it somewhere else into another destination, and therefore you need to have a parallel kind of operation that happens as you consume the data. These days, if you work, for instance, with a web server, that has its own thread pool. And interestingly, a thread pool can and should be made a virtual thread pool. And Tomcat and Jetty and others have already added support for Java 21. So you should, out of the box, even if you're not exposed directly to threads, you should see them become faster and more efficient. To your question, there will be always applications that require direct low-level thread access. But for everything else, including web applications, since Java 21 is it's a standard release, all of the major application providers, they are onboarding on this. So you don't know directly that they are using it, but they will be using virtual threads, and therefore the memory footprint ultimately will be much lower than what you have. And that goes back to Scala as well, and I hope they do this as well. But I know that Tomcat and Jetty and Spring, which is also using heavily multi-threaded and behind the scenes, have already adopted virtual threads. So this is major. That's the number one feature of Java 21 in my
Okay, interesting.
Yeah, and the other one, which is also very related to virtual threads, it's structured concurrency. Structured concurrency is, if you've ever programmed with threads, you fire a thread and you were basically subscribing to a notification to receive an update to the thread you've just started, a notification telling you that the operation has been successful or something has happened. And that results in your code in what we call nesting. You can see this in JavaScript, where you have functions that you fire and then you listen to the results of those functions, because the direct return is not used, since these operations are asynchronous.
Callbacks, basically.
Yeah, it's actually called callback hell, because the more you nest, the more you listen to the callbacks of callbacks, the more you nest the structures, and it becomes virtually impossible to maintain that code. Java introduced structured concurrency, which again looks and feels like the Kotlin coroutine structured concurrency, which is great news, at least for me. And that becomes a feature available out of the box. What to me is the most interesting part is this many years in which Java did not move in this space of multi-threading and concurrency and structured concurrency. There have been solutions that came about. Akka is one of them. Kotlin coroutines is another one of them. And there's another one, which is the RX Java, which is using another approach, which is the approach of observables. There's an approach in this structured concurrency world which works with another way of structuring this using the so-called observables, and it's been introduced in Microsoft, I think, and the C# at the beginning. Java has adopted it in a project called the Project Reactor and RX Java, and it's been adopted and made part of the core Spring offering by the Project Reactor is owned and funded by Spring. And now, since Java is at Java 21, has released structured concurrency, they are not compatible. They resolve the same issue, but they are just not compatible. And for the people who've adopted RX Java, if they want to maintain structured concurrency, they could stay clearly on the RX Java. However, the other option is to use the structured concurrency that comes natively in Java. So it would be interesting to see.
And what about these virtual threads? I mean, is there any overlap would you want to use structured concurrency and virtual threads?
Yeah, that's exactly how this is meant to be. So structured concurrency is built on the virtual thread. So it is part of the same story. What makes this interesting is how will the Project Reactor be seen by the community itself? As it's been seen before as solving the structured concurrency issue, now it is, I wouldn't say made obsolete, but there is a strong competitor in the language itself to solve the same thing. It will be interesting. For people who used Kotlin and coroutines, that's going to be yet another interesting story there, because I think Kotlin is a very relevant language, and it will stay this way due to its front-end, back-end aim. You can write Kotlin Android apps, for instance, even like any sort of native apps you can write in Kotlin. That makes it extremely compelling for such applications. But Kotlin itself as a language has many features that Java didn't have, and Java is catching up slowly with the other ones. And it will be interesting to see, especially for backend projects, how the decision will come about when choosing either or. Because Java, with all the things that it's been enhanced with, becomes a good alternative, if not a good mainstream alternative.
I see.
For people who traditionally, because Kotlin is not a new language, traditionally would have chosen Kotlin to start a new project. We'll have to see. Watch this space.
Watch the space, but lots of activity.
It's interesting stuff. And there's two more. I'll go very quickly through them. One is sequence collections. Something that came about for me, I was
sequence collections.
I will tell you what this is. You will know this. It is in Scala. You have this since forever. Collection.last, collection.first, collection.next. this was not available in Java. It's
Ah.
shockingly true, but it's something that I was sorely missing. Kotlin has this, Scala
Okay.
has this, and it's become a pretty normal way of accessing collection elements. Finally, Java has it. So this is a bright spot in Java 21 for me. And the last one I have, it's something that every other language that I can think of has and Java didn't have, which is a string template. And you can have in Python, or I think in Scala as well, you say hello, and then you put the variable name with a $sign.
Oh, right. You never had that before?
No?
No.
New.
In Java, really? Oh my God.
This is new in Java 21. Yeah, this is an amazing thing. And they don't have $sign because of a limitation with the keywords that Java has. So the way to say hello, Florin, for instance, where Florin is a variable of named, call it name, you can, to make a string template out of it, you say hello, / curly brace, name, close curly brace.
That's fairly horrible, but yeah.
Well, it's once you read the behind the scenes reasoning, it's that's the way it is.
That's just But that's interesting. Yeah, because I mean that kind of templating, obviously, I guess it started. Well, I don't know if it started, but I first saw it in like web templating language, right? Like Smarty from PHP, for instance, had that kind of thing where you had a template and you just want to fill it full of variables, and then in Django templates.
Oh yeah,
Python framework, you have that, right?
Python as well. C has it as well.
But I'm totally used to it from Scala
absolutely, it is a native feature of any modern language. Java finally has. There's a few more things that Java has introduced.
So it's interesting. It's interesting how the language designers look at other languages, right, and take bits from here and there, and they all kind of evolve.
Fascinating. And Java has something called record, which is a data class. I don't know the name in Scala, but in Kotlin they're called data classes. They've been introduced also a long time ago. Scala should have them as well. It's like structs in C. Where you just have a static immutable data structure that you instantiate once. So Java has introduced this thing called record a few releases ago, which again, like you're saying, has been borrowed or.
I mean, Microsoft had Active Record or something, right?
That's right. It's been an inspiration from other languages, and there was issues with that as well, but now it's finally in the language. And now with Java 21, they have pattern matching on that, some smart pattern matching on records, which is another feature. It's much more technical to explain, and I don't find this exciting enough. Less exciting than string templates, for sure. That's Java 20. That wraps up Java 21.
Java 21.
Yeah.
Thanks, Florian. Yeah, you heard it here. Yeah, I guess we'll look at upgrading our applications at some point.
Yes, and they have to. Java 21 is a long-term release train, I think. Don't quote me on this. There is also a garbage collector, which is supposed to be more performant as well. So out of the box, you get not just these new features that you might or might not use, but you get performance increases, and everyone wants performance improvements without changing much. And this is one of those.
Okay. Interesting. Yeah, cool stuff. So maybe I carry on on the Java thing and this JProfiler thingy. Should I?
Of course.
Yeah. So as I mentioned the other day, we had to do some kind of a little bit forensic digging into our application, and I got into trying out this JProfiler tool. Maybe I share my screen. Yeah. So we get a bit of echo from one another. But anyway, I'm running actually this app. It's actually the OBP API. And basically you can, I'm in IntelliJ idea here. And basically, once you've installed your JProfiler, it's a commercial tool, by the way, right? So and not that cheap. But you run your application with profiling turned on, and then you get immediately you can kind of look into your JVM, right? Your Java virtual machine. You can like see objects that are being used, right? And the object counts kind of in real time. And then you can dive further deeper into it. So you can get some snapshots and so on and so forth. And I found this pretty interesting, and we've used it for some success recently to kind of tune our application a bit. We were talking about threads earlier, right? So you can see the threads. So this is the Jetty threads here, etc., etc. We would one of the things we looked into recently was switching to a new database connection manager, because we found in one of our installations that the connection to the internal database was not very reliable. So we switched in this connection manager called Hikari CP, and you mentioned, Florian, that it's used by Spring, I think, right? And
Hikari became the default DB connection pool for RDBMS or relational databases. I think they won the recent wars, let's say, of DB pools. There used to be many; they're still around, but Hikari seems to be.
Yeah, exactly. Yeah, we use that, and in order to kind of drive some of this like this kind of analysis of our application, I learned a bit of Golang. Maybe I can show a bit of that.
Before that, I think you should share the story of the caching issue you had that solved with the JProfiler. That is an interesting bit of
so
war story.
Yeah, war story indeed. Yeah. So we had an endpoint or so, and we had some common code which looked at some input parameters for like from date and to date, actually. So you could call a REST API, put the from date to date, and get a bunch of results back. And we were actually defaulting the from date and to date. So if you didn't supply a from date, we were defaulting it to epoch. So 1st of January 1970, the beginning of the Unix time, basically. And that was not problematic, right? Because that's a kind of static thing; it doesn't change. But we were also setting the like the to date. We were setting it to the current date time, right? And from a kind of developer's perspective, that's nice, right? Because you always get the very latest data and so on. If you don't set it, it just defaults to the current time. But the problem was that we were caching that, and on our like development machines, so not a problem really so much in production, or not so obviously a problem in production, but on development machines. And this is I found through the JProfiler. I just suddenly saw millions and millions of objects of a certain type, which and it just, my intuition just said, well, no, that's not right. And it turned out that our cache keys, so whenever you have a cache, right, you have a key, which may be, I don't know, the name of somebody or the user ID, or in this case, it was like a query to a certain table. And that cache key included the to date. And because that was always changing, we were forever creating more of these objects in memory. So so we had two solutions. One was to get the cache, realize the cache should not be in memory, put it out to Redis. So we flicked that switch, as it were, and then just not allowing this default. Or actually, we decided to just put a date in the future, so the year 4000, January the 1st, year 4000. So we went from millions of objects down to one, basically.
Nice.
Did we find some other stuff? Yeah, we also used JProfiler. So we were opening a file to look at some Git properties. We weren't closing that. We saw these file pointers adding up. So yeah, so it's been a really useful tool, actually. And I think I think there's probably lots of mileage left in it as well.
Yeah. Now, for what it's worth, IntelliJ, the Pro version, has a profiler built in as well. I have used it in the past. With good success, I must say. This JProfiler, I've used that before, not in the recent versions, but it is a very rich tool itself. It's amazing how much things you can find out, especially discovering or uncovering your own sloppiness.
Exactly. You just, even though you try and be dry, right? You try to, follow all these good principles, functional programming, don't repeat yourself, keep it simple, stupid, all that kind of stuff. But, sometimes there are bugs there, right? And that is really useful to use such a tool. And the other thing that I wanted to show just briefly was Golang, right? So I obviously I heard about this language a while ago, but I thought, always good to learn a new language. And I was thinking about Golang and also Rust, and I thought, well, like what I heard was that Golang is like a kind of it's a simpler language, right? I think Rust has many more features, but I just spent some days writing a bit of Go, and so this program, this script here, it has a bunch of command line parameters. Whoopsie doopsie. Bunch of command line parameters. Oh, okay. So this is on my local host, so it doesn't matter if you see the password. And so what you got? So you've got, these are your imports. And I also used ChatGPT, by the way, to create some of this stuff. So, you're familiar, Florian, that when you have these kind of structures in a programming language and you want to go between JSON and your internal kind of structures. So in Scala, you have case classes, and in Golang, it's structs. And the syntax is a little bit tricky, right? So this is fine for a string. So in my JSON, I want it to be called token here, or here I want it to be user ID. And that's fine when you don't have various nested things. But, whenever you're learning a new programming language, you sometimes, yeah, there are little bumps of learning, right? So how do you, I don't know, how do you have nested JSON structures or something like that? And so I just put this question into ChatGPT, and I knew some keywords, right? So I knew the way to do it with Golang was to marshal or unmarshal, so that was a keyword. And I just said, please write me a Golang program to unmarshal this JSON, right? And I just gave this block of JSON, which is here, which I got back from the OBP API, and it basically spat out what I needed, right? I'd already done this myself, and then it just gave me the rest. I think I don't know. Actually, I don't know. Obviously, I have this commented out here, so maybe there was some problem with this. But basically, it was pretty. I think it saved me, a couple of hours, I guess.
I am sure of this.
Yeah,
I am at the moment hooked with GitHub Copilot.
Yeah, you mentioned that. Yeah,
amazing.
Cool.
We should do a deep dive.
Let's do a session on that. Yeah, sometime. Yeah,
because it is comparable to what you're saying, much closer to the code, so you can code as you go, and it's
right.
Copilot gives you inline all of these options almost without asking. An amazing achievement.
Yeah, interesting. So that could be the subject of another pod, maybe. Huh?
This is very cool. You showed me this before, and this is supposed to do a multi-threaded.
Yeah, so I mean,
performance kind of.
So it's not firing off. It's not pretending to be multiple clients. So I actually used the Google App Engine to and run this on Google App Engine, and just literally get up a few different terminals and fire it off on.
I see. So you fire.
Just fire multiple copies.
Separately.
Yeah, multiple. So it's doing nothing fancy there, but it's pretty easy that it runs on the command line, right? So here are my kind of command line prompts and stuff. A little bit of documentation. And then like I'm getting a token, so this is making a post, like a post call to a HTTP, and the kind of model in Scala, or certainly with a framework we use called LiftWeb, you have this idea of a box, so you can return either a kind of full result, which is all good, a kind of empty thing, or an error, right? But in Golang, the kind of pattern is that you return your data here or some error, right? And then you check if the error is nil or not nil, and then you kind of carry on, right? And you can have you can do kind of early return. You can return early from the function, and that seems to be acceptable way to do it. So here you've got little nested loops, right? And here I am trying to hit my cache or not hit my cache. So I wanted to exercise the database via the API, so deliberately changing offset and limit and stuff, so that I would force database hits and stuff. And I mean, pretty easy. Here's this string templating that we were talking about a minute ago that Java finally has, right? So and you have this in C++, right? So you have like an integer is different to a string, and
this Java has as well. I don't know if in Golang you can have this my_rd count quoted as a variable name inside the we got string.
Okay.
So I don't know that. I'm not a good Go developer. Good enough to tell you off the bat if this works. So this has been introduced in Java as well a while back. This %d %is.
Yeah, and the really interesting, nice thing about Golang is it's like super strict, right? So watch this. Watch this. If I just say, var florin, right? And it's a string, yeah?
Yeah.
Look, it doesn't like it. Why doesn't it like it? Because it's not used yet, right? It won't even let me run my program because because I've got a variable which is defined and not used, right?
Very nice.
Yeah,
Yeah.
so stuff like that is cool, I think, and okay, so at the start of lockdown, Florian, or just before then, I decided to learn C++, right? My God, I mean, obviously you can't really compare Golang to C++, but what a pleasure Golang is to learn, right? I mean, so easy. I mean,
well, it's been invented so many years later after all of the
yeah. Of course.
Plus, they made it simple enough. They have I think they have a keen interest in keeping it. I don't even know 20 pages long. The language spec, it's in minimal.
Right. Yeah. That's interesting. Yeah, their approach is to have very limited feature sets, so everyone writes the same, right?
That's
and
right.
Then you got these kind of compile types. It's not really compile time, right? But it's kind of immediate, like warning or checking the code.
Yeah, which is again this typed languages.
Yeah.
Go is one of those. It's part of the native feature set of the language. With JavaScript, you have linters.
Right.
They aim to do the same thing, but you have to run them explicitly. You have IDEs. You have to embed this linters, otherwise they will just not be. All of these unused variables will be as valid as anything.
So I had some trouble setting headers. I don't know why. Like there's a couple of ways that you can make kind of post requests. And anyway, this was the way I got it to work. So this is setting a kind of header.
Okay.
And making the request. But it's cool, and with the same library, you have you have an HTTP server as well. So I haven't used that, but obviously Golang is used for kind of network stuff, right? A lot, and
you ended up using it for the same kind of use cases I was trying to use Go, which is more or less scripting. What we used to do before with, let's say, Python.
Exactly.
Now this Go seems to be pretty native for those kind of.
Yeah, and it's pretty easy to print out data, get. Yeah, so basically, when you get as long as you define your struct here, so then you just unmarshal unmarshal your thing into a variable. So this is like a pointer,
right?
So I'm getting the ID, and it knows the kind of type that I'm trying to put it into, and gets the data out. So here's getting this kind of big structure of stuff.
Winner. How long did it take you to do this?
I don't know. I mean, I don't know. I think the truth would be in the Git commits, right? So, so maybe let's have a look. I don't know.
Well, hours versus days. That's what I was.
Well, I mean, to learn it from scratch, right? So here's
the 16th. Okay, that was the latest.
Yeah, you can see it's on Git. It's on GitHub, on the OpenBank project GitHub, right? So as in the OBP load tester. Where's the? I don't know how I see file history. I don't know. Yeah, so I started on the 24th September, and So I guess a month, right? I mean, you know,
Yep.
from 0 to. I mean, obviously, I'm not working on it. Wasn't working on it full time.
Of course.
Right? Yeah.
Decent.
Plenty of other stuff to do, but yeah, I enjoyed it, and I think, you know, we're going to use more Golang in the company to serve the others.
Yeah, I think it's a wise idea, especially when you compare this to C++.
Yeah. Well, C++ is that's purely a kind of fun stuff for me. Like,
good.
Yeah.
This should conclude the news.
Yeah. The news of Java 21 and Simon learning Golang.
Java 21 to go via JProfiler.
JProfiler. Yeah, nice.
Cool.
Good. Then thanks for watching, everybody. And
yeah,
you have a message to anyone for it? Or?
Yeah, stay close to technology, stay close to Java, and stay close to the JVM, and then keep coming back to listen to our ramblings.